This is problem number 55 from the Gene Coley textbook, and it reads that an 18 kilogram box is released on a 37-degree incline and accelerates down the incline at 0.270 meters per second squared. That's a formatting issue there. Find the frictional force impeding its motion, and then secondly, how large is the coefficient of kinetic friction? So setting up a free body diagram, assuming the box is sliding down, let's say down the negative x-axis, I'm going to get forces that look like this. I've got the y component of the weight vector and the x component of the weight vector. I've got a normal force, F sub n, and a frictional force, which is retarding the acceleration down the incline, so it is directed up the incline. And I have some initial conditions. I have that the angle theta is equal to 37 degrees. I also know that the mass of the box is 18 kilograms. So let's first, by starting the force, by finding the frictional force impeding its motion, let's first write the sum of the forces in the x direction is equal to 0. And the answer to that, of course, is no. And the reason is the box accelerates down the incline. So therefore, this force right here, the x component of the weight force, has to be larger than the frictional force, otherwise the box would not begin to slide. So if I assume that to the left is the negative direction and to the right is positive, this becomes negative mgx plus the frictional force is equal to F net. Notice that in this case, because mgx is larger, that's going to give me a negative acceleration in for net force once I ultimately substitute in mass times acceleration there. And it should be negative because it's going in the negative direction. So what I'm going to do then is kind of leave that alone for now and solve this for frictional force. The frictional force is going to be equal to I'm going to add mgx to both sides. It's going to be mass times acceleration plus mgx. Now keep in mind that the acceleration here is going to be negative, so therefore, since I've decided that negative here is down the incline, then this acceleration right here is going to be negative 2.70. All right, so now I can solve for the frictional force. I can substitute in F sub Fr. Mass is 18 kilograms. The acceleration is negative 0.270 meters per second squared. And I'm going to add to that mg times the sine of theta because it is the horizontal component, but it's on an incline, and theta has referenced the y-axis. So now the frictional force, if I do one more numerical substitution, is going to be 18 kilograms. I should have done this in one step. Negative 0.270 meters per second squared, plus the mass 18 kilograms times g, which is 9.8 meters per second, times the sine of the angle of inclination, which is 37 degrees. When I put that into my calculator, I should get a frictional force of 101 newtons to 3 sig figs for this problem. That answers part A, which is find the frictional force. Part B then says how large is the coefficient of friction. So I'm going to go ahead and continue this problem by saying that the frictional force is equal to mu times the normal force. Here again we see that we do need the normal force, and that's going to come from understanding the forces in the y direction. The sum of the forces in the y direction is equal to 0, and we know that because the box is not accelerated in the perpendicular axis. So this becomes F sub n minus mgy is equal to 0, or I can write that the normal force is equal to mg cosine theta once I add this to both sides and then substitute the trigonometric function in for the y component. This normal force here is going to get substituted in for normal force down here, and I'm left with a frictional force is equal to mu times mg cosine theta, and then finally mu, or specifically mu kinetic, since it is sliding down the incline, is equal to the ratio of the frictional force F sub Fr divided by mg cosine theta, which is the normal force. I know the frictional force, it's 101 newtons. I'm going to divide that by mg cosine theta, which is going to be equal to 18 kilograms times 9.8 meters per second, and I have to remember that to multiply that by the cosine of 37 degrees. And when I run that through my calculator, I get a coefficient of kinetic friction of 0.719 to 3 sig figs, which is my answer then to part two, or the second part, how large is the kinetic coefficient of friction?